Hi, we're going to go ahead and I'm going to do a video on the chi-squared chapter 11 stuff that we're going to do. And I'm going to do the practice just to walk you through it. So the big thing about chi-squared is you're dealing with categories. So please remember when you're dealing with categories, you're dealing with qualitative data. And that's data that's been put in categories. So as you can see on the screen right now, I have an example of stuff that's been in categories. So let's go ahead and work through this. So a sample of 218 commercial businesses were surveyed for a recycling one commodity. A commodity here means one type of recyclable material such as plastic or aluminum. The table below shows the business categories in the survey, each of the sample sizes for the categories, and the number of businesses in each category that recycles one commodity. Based on the study, on average, half of the businesses were expected to be recycling one commodity. As a result, the last column shows the expected number of businesses in each category that is recycle one commodity. At a 5% significance level, perform a hypothesis test to determine if the observed number of businesses that recycle one commodity follows the uniform distribution of the expected values. Okay, so let's look at this. So here I have business types. I have office, retail, food, manufacturing, medical, hotel, and mixed. And then I have the numbers in each class. Here I have the observed numbers, and here I have the expected numbers. For chi-squared, the observed and the expected are the most important to me. I really need those to look at so I can compare to see if the observed is similar to the expected. So down here, it wants to know the hypotheses. So if we go up here, it says, determine if the observed number of businesses that recycle one commodity follow the uniform distribution of the expected values. So what we want to do then is we want to look down here and we're looking for a distribution. So what we want to see is that the distribution of the businesses that recycle one commodity fit the expected number that recycles one commodity. So I'm going to look at that. So it's going to be this one. That's what I want to know. I want to show that the observed will equal the expected. So, all right, and then I'm going to go down here and I'm going to do part B. So part B is my alternative, and it wants to know basically what the opposite of my null is. And since my null is the distribution of businesses that recycle one commodity fits the expected number, all that would be is the distribution of businesses that do not fit. So I'm going to go down here, and basically it's the exact same hypothesis. The only thing that's different is this says fits and this says does not fit. That is the only difference, okay? All right, so now I get to part C, and it says, what's your degrees of freedom? My degrees of freedom is the number of categories. So let's go back up here. 1, 2, 3, 4, 5. 5 categories minus 1. So it's the number of categories minus 1. So my degrees of freedom are 4. Here it says state the distribution for the test. This is not a t-test, so you can ignore those. This is the expression for chi-squared, and I want to put chi-squared with the 4 next to it, because that means this is a chi-squared distribution and my degrees of freedom are 4. Don't put chi-squared in 5 because that's the number of categories. We always have to use the degrees of freedom. All right, so here it says, what is the test statistic? So what I'm going to do is let me go to this website that I have. So I'm going to enter this data from the problem into this website. So what you're probably going to want to do is have 2 browsers open at the same time, because I've got to get this data in here to the other screen. So let me go ahead right fast, and I'm going to quickly go in there and I'm going to enter it. So let me do something right fast. So I've got office, retail, and all that. Okay, so I'm going to write this down. So what I can do is when I go to the other screen, I can enter it. I do need to put the decimals in there because they are important. So if you see right here, what I'm doing is I'm writing down office, retail, food, manufacturing, and hotel. And then I'm going to write down my observed and my expected over here. So let me go back to my website. This website that I keep talking about, the link is found on the handout I made or in the PowerPoints. So let's go ahead. This is office. This is retail. I'm not going to type the whole thing out. I'm just going to type the first word, food. Do manufacturing. I'm going to make that small, and then I'm going to do hotel. Okay. So then I enter in my categories and I hit next. It wants my observed. In this case, it wants my observed the numbers that were given to me. So 17, 29, 35, 21, and 7. And let me go back right now and let me show you the problem. So this is where I'm getting it, observed numbers. I'm pulling those right there. So then I go back and then I need to do my expected, which was 18.5, 25, 27.5, 27, and 11. All right, again, if I go back here, you'll see that I wrote down the right numbers. Your numbers when you do these practice problems on your own will be different from mine. The numbers in red in any of the problems changed. So don't worry about the numbers in a class. I'm not concerned about that, okay? So now I go back over here and I've entered all my stuff. Remember, it's set at a 5% level of significance. Let me go back to the problem and show you. See, it says at 5% level of significance. That means I'm going to leave this one, that 0.05 level chosen. If it doesn't give you a level, just use the 0.05. So I hit calculate chi-squared. So if you see here, it says success. The data below should be self-explanatory. And what happened here is because with qualitative data, you really can't find the average of stuff. So here what they're doing is they're kind of taking the differences between the two, squaring them, and then dividing the difference squared by the expected. So you don't have to worry about that. I did show in the PowerPoint how to do it by hand. I do not expect you to do it by hand. So what we're going to do right now is, look here. Here's my chi-squared value. It's 5.595. And my p-value is 0.232. So what I'm going to do is I'm going to go back to, my data, and I'm going to go over here, and then I'm going to go, what's my test statistic? So my test statistic, that's my chi-squared. So it's going to be 5.60 because it was 5.595 and I had to round up. My p-value is 0.232. I'll put a 0 on it because it only gave me 3 spaces. So explain what your p-value means for this problem. Okay, and I wrote this in the handout, and it's kind of tricky, but once you see it in the handout, that's all you have to put every time. So the first thing you want to look at is it saying, is the null false or is the null true? It's always got to be that the null is true. And then the next thing it wants to know is there's an equal chance, there's a chance equal to the p-value that the value of the test statistic will be equal to or greater or equal to or less. It's always going to be the equal to or greater. So again, if your null is true, there's a chance equal to the p-value that the value of the test statistic will be equal or greater than the calculated value. And it has to go back to, there's a table that we could look at to compare the test statistic to a value of a chi-square distribution based on our degrees of freedom. We use the p-value because it's just easier, right? So down here, it wants you to sketch a picture. This is the best part of chi-squared. Chi-squared values are always right-tailed test. Your p-value will always be right-tailed or a greater than. So this up here is two-tailed. That won't work. This is between, and that won't work. This one is left-tailed. That won't work. So this one is the correct one. It's the one that's right-tailed, and that will always be the case. So down here it wants my alpha, and again, remember it's 0.05 because it's a level of significance. All right, so we go back and look at our p-value, which was 0.2320, and that was bigger than our alpha. So because it was bigger, we do not reject our null. And another way to think of it down here is since the alpha was bigger than the p-value, we reject the null. So the way to think of that is you're going to flip the signs to figure out which one to use. Okay, we didn't reject our null because we knew that because I did the people eat fish from the river Nile. So we know it's not the first one and we know it's not the last one. Okay, so we know that the alpha value is a lot smaller than the p-value. So we did not reject the null hypothesis. All right, so if we didn't reject the null hypothesis, we need to see which one is true about this, okay? And I went ahead and took off the points on this one, on the actual one, because I don't think it's a very good problem or the way they're asking it. So I want you to go ahead and basically just ignore this last part because, again, I don't really like the way they're asking it. And it's kind of confusing because we're not going into a lot of theory. So the answer would be this at the 5% level of significance. And again, when you work on this problem in the homework, and even if you see it on the test, just put one of the answers down because it's going to mark it wrong probably, but it's not going to take off any points, okay? Let me know if you have any questions, and this is how you do chi-squared. Oops.